All right, so we're going to learn how to solve exponential equations using logarithms. Now, as a quick review, as a review, remember in one of the previous lessons, you learned how to solve exponential equations by getting same bases. So let's remind ourselves how to do this. So, and we're gonna do a very simple example. So we're gonna solve using same bases. So solve using same bases. And as a very simple example, let's suppose we have 3 to the x power equal 27. And you can look at this very easily and tell me what the answer is, what the solution is. So 3 to what power is 27? Well, 3 cubed, right? So the solution would be x equal 3. And again, that's a very simple example. But I'm going to use this example and do this problem using logarithms in a little while. But I just want to remind you this. So the most efficient way is whenever possible when solving exponential equations is to get the same basis. That's the most efficient way. But not all exponential equations can be rewritten using same basis. Okay, so if you remember, what we did here was we asked ourselves, is there any way I can write 27 as the as 3 raised to the same raised to a power or to an exponent? And the answer is yes. So remember, we can write 27 as 3 cubed. And then we remember the fact that whenever the bases are the same, then that means that those exponents have to equal. So then that means that x must equal 3, right? All right, so that's a very simple example. In those lessons, you had much more difficult problems to deal with where you had to get the bases to be the same. But what we're going to do now is we're going to solve the same equation using logarithms. So let's go ahead and just rewrite this over. So I have 3 to the x equal 27. All right, now one of the things you have to remember that's going to be needed in these problems is this. So you have to remember that your calculator uses base 10. So remember the LOG button, that's a common logarithm. That means common logarithm. Common logarithm is base 10. Your calculator also uses the natural logarithm. And so that's base E. So base 10, base E. All right. And so what we can do here, if I want to solve for x without using logarithms, if I want to solve for x using logarithms, notice that the variable is in the exponent. So what I need to do is to get this variable out of the exponent. And the only way we can do that, if you cannot get the base to be the same, then the only other way to do that we can do algebraically is to use logarithms. All right, so I am going to then do this. So we're going to take the log of both sides. So remember the phrase I said, we're going to take the log of both sides. So I'm going to say the log of 3 to the x equals the log of 27. Notice I'm using a common logarithm here. Remember, this base right here, if you don't see it, it's understood to be a 10. And so now I can use the power rule. So remember the power rule. So the power rule says that if you have the log base b of m to the x, let's say, I can rewrite this exponent as a product. So I can say, well, that's the same thing as x times the log of m base b. Okay, so that's the power rule. So then that means then I can rewrite this as x times the log of 3. So that's x times the log of 3 equal the log of 27. And so now if you notice, and remember I got to get x by itself, so now if you notice I'm multiplying x by the log of 3. The log of 3 is a real number. Let's say it's a real number. So for example, if you take the log of 3 and then press equal, you get this real number, right? 0.47712 and so on. All right, so it's a number. So to get x by itself, right now multiplying x by the log of 3, the opposite of multiplying by the log of 3 is to divide by the log of 3. So I'm going to divide both sides by the log of 3, just like this. And so the log of 3 divided by the log of 3 is 1. 1 times x is x, and so I've solved the equation. X equals the log of 27 divided by the log of 3. All right, so I've solved this equation. There's your answer, right? There's the answer. There's the exact answer. But I just want to remind you, so you may say, well, I thought the answer was 3, right? It is. This is actually 3. So watch. If you take the log of 27, look what happens. The log 27, make sure you close the parentheses though, divided by the log, log, of 3, make sure you close the parentheses, and press equal, you get 3. So this means the same thing as 3. See that? All right, now one of the mistakes people make is this. So I just want to remind you. So I'm going to write this here. So there's a very common mistake people make. All right, so they see this 27 divided by 3 and they think 9, right? Because if you look at this, 27 divided by 3 is 9. But you have to be careful. That's not 27 divided by 3 that you see here. That's the log of 27, which is a real number, divided by the log of 3, which is another real number, right? So that does not mean the log of 9. And that's a common mistake. So we know that the log of 27 divided by the log of 3 is 3. We know that. So if you said that's a log of 9, check yourself. Use your calculator. Log of 9, press equal, that is not 3. That is 0.9542 and so on. All right? So just be careful. Don't make that overgeneralization here. Okay? All right. So someone else, now notice how I solved this problem. I solved this problem by taking the common logarithm of both sides, by taking the log of both sides. But remember, your calculator also has a natural logarithm function, so ln. So what we could have done is, instead of taking the log of both sides, I could have taken the natural log of both sides, just like this. And so then using the power rule, I can rewrite this as x times, so x times the natural log of 3 equals the natural log of 27. And then to get x by itself, I'm going to go ahead and divide both sides by the natural log of 3. And so the natural, 3. And so the natural log of 3 divided by the natural log of 3 is 1. X times 1 is x. So I get x equals the natural log of 27 divided by the natural log of 3. And so there's your answer. And you may say, well, those things look different. They do look different. They are. They look different. One has a common logarithm and the other one has a natural logarithm. But they are equivalent. Because when you use your calculator on this, using natural logarithm, so the natural log of 27, close the parentheses, divided by the natural log of 3, close the parentheses, you get 3. Oops, sorry. I forgot to divide. All right, so let's do it again. So the natural log of 27, close the parentheses, divided by the natural log of 3, close the parentheses, equal, you get 3. All right? So and the reason why those are equivalent, by the way, is it has to do with the base change property, or your base change formula. So remember, the base change formula, if you recall, said this. I can change, so if I have the log of m base b, I can change the base to any other base I want to. So if I want to change it to a logarithm, a common logarithm, I can say this. That's going to be the log of m divided by the log of b. If I want to use natural logarithm, I can do the same thing. That's going to be the natural log of m divided by the natural log of b. If I want to, there's an infinite number of ways to do this. You can change it to any real number, um, to any positive number, I should say, base b, as long as, remember, the base can never be 1. So I can change it to log of m base a divided by the log of b base a. As long as a is a positive number, okay, as long as a is a positive number, and a, remember, your base can never be 1. So that's the base change formula. So one of the things you did real quickly, just to remind you, is this. So if I want to use a calculator to determine what the log of 8 base 3 is, like this, now remember you did some problems like this, and I just want to remind you real quick. You did some problems like this where you had the log of 8 base 2. And you use the property that 2 to what power is 8, right? So remember that? 2 to what power is 8? Well, the answer is 3. The answer is 3. 2 to the third is 8. But I could use the base change formula to find that this is actually 3. So if I have the log of 8 base 2, then using the base change formula, I can use either logarithm or natural logarithm if I want to use my calculator. And so I could say, well, that's the log of 8 divided by the log of 2, right? And if I use a calculator, hopefully I'll get 3. So the log of 8 divided by log, oops, I did the wrong one, log, log, of 2, close the parentheses, equal 3. If you want to use, that's 3 right here. If you want to use natural logarithm, same thing. You could have said, instead of saying base 10, you could say base e, natural log of 8 divided by the natural log of 2. And so the natural log of 8, close the parentheses, divided by natural log of 2, close the parentheses, equal 3. All right. So the base change formula says I can, given this situation here, with some base, I can change this base to any other base as long as the base is positive and the base cannot be 1. All right, so if I go here, then I could say that's the log of 8 divided by the log of 3, right? And then that's going to be an approximation, by the way, because 3 to no whole number is 8. So so you're going to say the log of 8 divided by the log of 3. And you get this right here. And let's go ahead and approximate to 2 decimal places. So 1.89, okay? And instead of using common logarithm, you could have used the natural logarithm. So you could have said the natural log of 8 divided by the natural log of 3. You'd have still gotten this same approximation. So the natural log of 8, oops, let's do it again. Natural log of 8 divided by the natural log of 3, and you get the same thing. Okay? So the point is this, that the reason why those two things I'm circling are equivalent, even though one has even though they have different bases, is because of the change of base property, the change of base formula. Okay? All right, so let's look then at number 1. So number 1, you want to solve this exponential equation, and you want to write the exact answer, solution, and you want to approximate the solution to the nearest thousandths place. All right, now notice that in this particular case, there's no way I can do this by getting the same bases. See, this is 5.31. 3 to no whole number is 5.31. All right, so then that means I'm going to have to use my calculator. I'm going to have to use logarithm or common logarithm. All right, now, so you want the exact answer. Okay, so since I want to approximate, we're going to use either, remember I want to use the calculator, so we're going to use either common logarithm or a natural logarithm? Base 10 or base e? All right, so we're going to do it both ways for this one. So let's go ahead and do this problem by taking the log of both sides, just like we did earlier. All right, so notice this time I'm using the common logarithm, base 10. So I'm going to use the power rule now. So to rewrite to get the exponent, to get the variable out of the exponent, I'm going to use the power rule. So I'm just going to be x times the log of 3. So x times the log of 3 equal log of 5 and 31 hundredths. And then to get x by itself, right now I'm multiplying the log of 3, so I'm going to divide by the log of 3, just like this. Notice how it looks. And then log of 3 divided by the log of 3 is 1. 1 times x is x. I get x equal the log of 5 and 31 hundredths divided by the log of 3. And that is your exact answer. That's the exact answer. Now let's go ahead and approximate this. All right, so we're going to approximate this. So using your calculator. So notice, also remember that this says the nearest thousandths place. Sometimes they'll say, instead of saying the nearest thousandths, they may say 3 decimal places. So 3 decimal places means 3 digits behind the decimal point. All right, so we're going to say, I'm trying to get the glare out of the way. All right, so then we're going to say this. We're going to say the log of 5.31, close the parentheses, divided by the log of, now be careful, see the log and the ln are near each other, so don't mistakenly hit the wrong one. Divided by the log of 3, close the parentheses and press equal. And so that's what we get. All right, now remember we want to round to the nearest thousandths, right? So I'm going to go ahead and just rewrite this. Just to elaborate on something. So 5.519727 and so on. All right, so the nearest thousandths is right here. So the 9 is in the thousandths place. I have to look at this digit. Since this number right here is 5 or greater, I've got to add 1 to the 9. When I do that, so remember you got to add 1 to the 9, right? When I do that, 9 plus 1 is 10. All right, so that's 10. So then this becomes 1.52. And remember, even this is a 0, right? You still have to show the thousandths place. So make sure you show the 0 there. Don't leave it off. Don't say 1.52. It's actually 1.520. You have to show the decimal place where it's being rounded off to. All right, so you're going to say 1.520, and that's it. All right, now real quickly, remember we could have, instead of using the common logarithm, we could have used the natural logarithm. So let's take the natural log of both sides. So I have 3 to the x equal 5.31. I'm going to take the natural log of both sides this time. And again, same idea as we did this one. I'm going to use the power rule to get the variable out of the exponent. So I get x times the natural log of 3 equals the natural log of 5.31. And then dividing both sides by the natural log of 3 to get x by itself, we're done. We are done. We get x equal the natural log of 5.31 divided by the natural log of 3. There's your exact answer. And then to approximate it, now remember we had the discussion a while ago, even though those look different, remember this is base 10, this is base E, they're equivalent because of the change of base property. All right, so hopefully you'll see that using your calculator, that what you get here will be the same as this. All right, so watch. So we have the natural log of 5.31, close the parentheses, divided by the natural log of 3, close the parentheses, equal, and you get the same thing. All right? Okay, now, in number 2, sometimes, you see when this is base 10 right here, when this is base 10, it is so much more efficient if you use log, because that has base 10. It doesn't matter. You could have used common logarithm. You could use natural logarithm here. It does not matter. And we'll do it both in this particular case, but you're going to see it's so much efficient if you see a base 10, that you use a logarithm. If you see a base e, that you use a natural logarithm. Okay? All right, so I see a base 10 here. So let me go ahead and just rewrite this. Oops. Let me do it over. So 10 to the x equal, and we'll leave some space here. All right, so I'm going to take the logarithm both sides. I'm going to use a common logarithm. I'm trying to be efficient. So I'm going to use a common logarithm because the base here is 10 right here. And so you're going to see why I chose that in a little while. And so now I'm going to use the power rule. So x times the log of 10. So x times the log of 10 equal the log of 7, right? Okay, now here's why I chose base 10. One of the things you learned in the past in a previous lesson was this. All right, so watch. Log of 10. You saw in a previous lesson that the log of 10 is just 1, right? So remember when you wrote this as equal, let's say x or a box, whatever, and then you changed this equation to an exponential, the base right here is understood to be 10, right? So you said 10 to what power is 10? Well, 10 to the first. All right, so that's a 1. So that's 1. And so x times 1 is x, so you get x equals the log of 7, and you're done. There's the exact answer, right? See how simple that is? And now approximating this, so this is just log 7. So approximating that, log 7, you get to 3 decimal places, so that's 0, so that's less than 5, so that stays 5 here. So 0.845, so 0.845. If you had, instead of taking the log of both sides, taken the natural log of both sides, let's see what you would have gotten. All right, so we have 10 to the x equal 7. So we're going to take the natural log of both sides this time. So now using the power rule, I'm going to rewrite this as x times the natural log of 10 equal the natural log of 7. All right, now be careful. Don't think the natural log of 10 is 1. That's not true. You can actually see that's not true, right? So the natural log of 10 is not 1. You can see that. Because remember, the base right here is understood to be e. So e to the first power is not 10. All right? Okay. All right, so then to get x by itself, we're going to divide both sides by the natural log of 10, just like this. And so the natural log of 10 divided by the natural log of 10 is 1. X times x is x. So you get x equals the natural log of 7 divided by the natural log of 10. There's your exact answer. There's the exact answer. They look different, but they're equivalent, and they look different only because this has base 10. Here you use base e, but they're equivalent. If I use my calculator now to approximate this, it will be this right here. All right, so watch. You're going to get the natural log of, all right, natural log of 7, close the parentheses, divided by the natural log of 10, close the parentheses, and notice you get the same thing. Okay, so 0.845. All right, but the point's this. Whenever you see a base 10, you're going to use a common logarithm. That's the most efficient way. If you see base e, like right here, number 3, what do you think you're going to use? You can take the log of both sides. You can use log. You can use a common logarithm. But it is so much more efficient if you use a natural logarithm. All right, so let's go ahead and do that. So we're going to have e to the x equals 4.8. So I'm going to take the natural log of both sides, just like that. Then I need to get that variable out of the exponent, and the only way I can do that is to use the power rule. And so this becomes x times the natural log of e equals the natural log of 4.8. And just like we did a while ago, you know what the natural log of e is. The natural log of e is 1, right? And you know that because of something you learned previously. So remember, ln means log base e, right? So log base e of e. And you change this to an exponential. So you said e to what power z? E to what power is e, right? So e to the first power. All right, so that's one of the things you learned. So the natural log of e is 1. X times 1 is x, and there you're done. There's your answer. Right here, there's the exact answer. And then to approximate this, you're going to say the natural log of, trying to get the glare out of the way, natural log of 4.8 equal, and to 3 decimal places, so let's see, that is right here. Since this digit is 6, 5 or greater, I got to add 1 to the 8, so that's 1.569. 1.569. All right. Now, if you had taken the log of both sides, you would have still gotten the same approximation, but the exact answer would look different, but they are equivalent. All right. So if you had taken the log of both sides, you would have said x times the log of e equal the log of 4.8. And then dividing both sides by the log of e, just like that. The log of e's divide out, so you get x equals the log of 4.8 divided by the log of e. All right, so that would be your exact answer. Now, here's the problem. You got to remember how to do this now. All right, so we got to approximate this. All right, so let's remind ourselves how to deal with the log of e. So, remember this is common logarithm, so you can press log 4.8, close the parentheses, divided by log. Now I've got to get that e, right? I got to get e. So remember, to get e, to get this argument here to be e, just e, you're going to use your e to the x button right here. That's right above the ln button. To get to that, you're going to press second e to the x. All right, so you're going to say second e to the x. All right, now remember, this right here, that exponent that I'm pointing to right here, that's e to the first. So I got to put a 1 right here. So 1, close that parentheses. So that parentheses closes this one, but then I got to close this one. All right, and so then you press equal and you get the same thing. All right, so just be careful. So in terms of using a calculator, some students struggle with finding out what with putting the log of e in there. So remember, this is e to the first power right here. That's e to the first, and you're also going to have to use your second function here, second, and then ln to get that e to the exponent. All right, so just be careful. That's why it's so much more efficient if you see an e to use natural logarithm. It makes things so much easier for you. All right, so let's look at number 4. Okay, so I see an e, right? So right away you know you're going to use a natural logarithm. But here's the problem. Before you take the natural log of both sides, you need to make sure that that number right here is a 1. All right, so you have 3 times e raised to the 7x power. Well, that's not a 1, but I can get that to be a 1 because right now you're multiplying by 3, right? So the opposite is to divide by 3. So that's 7x. All right, so you can divide both sides by 3, just like that. And so 3 divided by 3 is 1, so you get e to the 7x equal, and then 1,253 divided by 3 equal 451. So that's 451. All right, and so now I'm going to take the natural log of both sides. Don't take the log of both sides. You saw a while ago that taking the log of both sides will make it a little bit more challenging for you. Take the natural log of both sides because this is base e. And we know that the natural log of e is 1. So we have, so you can do this. You got to show this. All right, so now we're going to take that exponent, write it in front, so that's 7x times the natural log of e equal the natural log of 451. We know that the natural log of e is 1, right? So this just becomes 7x, just like that. But then you got to solve for x. So we have this linear equation now. And so to get x by itself, right now you're multiplying by 7. The opposite of multiplying by 7 is to divide by 7. And you're done. There's your exact answer. The natural log of 451 divided by 7. That's it. We're done. Right here. There's your exact answer. So there's the exact answer. Now let's approximate this. All right, so we have the natural log of 451, close the parentheses, divided by 7. Not the natural log of 7, that's just 7, right? All right, divided by 7. Press equal. And to 3 decimal places, since that's a 0, less than 5, this stays a 3. So 0.873. So 0.873. And that's it. All right, see how simple this is? Very simple. Okay, let's look at number 5. All right, so number 5, there's another e, right? So your base is e. So what are you going to use? You are going to use natural logarithm. It'll make things so much easier for you. All right, so let's go ahead and rewrite this over. All right, so here we go. Take the natural log of both sides. That's the only way I can get that variable that's in the exponent out of the exponent, is to use logarithms. And so now I'm going to use a power rule. So this becomes 2 minus 5x times the natural log of e. That's what that becomes. Equal the natural log of 721. We all know what the natural log of e is. The natural log of e is 1. That's 1. So 2 minus 5x times 1 is 2 minus 5x. Equal the natural log of 721. And then you notice you have this linear equation here. So you're going to get x by itself. So first I'm going to do subtract 2 from both sides, just like that. Now be careful. This is a little bit more challenging. Be careful. 2 minus 2 is 0. And 0 minus 5x is a negative 5x equal the natural log of 721 subtract 2. That's what you have here. Mistake people make is they want to rewrite. They want to say 721 minus 2 is 719, and they want to say, watch. They want to say the natural log of 721 minus 2 is the natural log of 719. That is not true. That is not true. Okay. This is the natural log of 721. So if I look at that, natural log of 721, close the parentheses, you get this number, right? 6.58. Subtract 2, you get that. That is not the same thing as a natural log of 719. So just remember 4.58, let's say. All right, so watch. The natural log of 719 is this, a totally different number. All right, so be careful. Leave it like this. And then to get x by itself, you're going to divide both sides by negative 5, and you're done. That's it. There's your exact answer. X equals the natural log of 721 minus 2 divided by negative 5. There's your exact answer. All right? Not difficult at all. Not difficult at all. Now, let's approximate this. All right, so you're going to say the natural log of 721, close the parentheses, subtract 2. All right, now that's the numerator. So listen carefully. Think of this as 2 terms. So these are 2 terms here. Put that in parentheses, or think of this in parentheses. So we're going to press equal now. You got to press equal. If you don't, if you say, right this point right here, if you say divided by negative 5, like this, that is not your answer. And I'll come back and talk about why. All right, so be careful. So here's the way I would do this. Since the numerator is more than one term, you have 2 terms here. The natural log of 721 and a negative 2. So what I would do is this, say natural log of 7 to 21, close the parentheses, subtract 2, just like this, press equal. So now I've found my numerator. Now leave this in your calculator. Don't write it out and approximate that. Only approximate your final answer. Only the final answer must be approximated. So that's your numerator. Then I got to take that numerator and do what to that? Well, I've got to divide by negative 5. Well, let's go ahead and do that. Divided by negative 5. And when I do that, that is your answer. So this is to the nearest thousandths. That's going to be a negative 0.916, right? So negative 0.916. All right, now, let me remind you, if you had done this, okay, watch. I'm going to write out what you're actually saying. So if you had done this, if you said the natural log of 7 to 21, close the parentheses, subtract 2, and then divide by, this is what you're doing. You're saying the natural log of 7 to 21, subtract 2, and then if you say divide by negative 5, then what's happening is this. You're only dividing this by negative 5. All right, this right here. So when you say divide by negative 5, oops, I did too many divisions. Let me delete this one. All right, divide by negative 5 and then press equal. That's what you get. That's not the same thing as this. See that? Because what you're saying, what you just did was this. You said the natural log of 7 to 21, subtract 2, and only this 2 is being divided by negative 5. When this problem says everything in the numerator has to be divided by negative 5. All right, so when doing it this way, that's going to be 6.98. So just be careful how you write this. So when there's more than one term in the numerator, when you get to that last term, then just do this. The natural log of 7 to 21 minus 2, press equal. So now that's my numerator. And then my denominator is just one term. Since that's just one term, just now say divide by negative 5. And then press equal. Okay? All right. Let's look at number 6. All right. Now, number 6, notice you don't see a base 10, you don't see a base C. So it does not matter. It does not matter whether you use common logarithm or a natural logarithm. The using either is not more efficient than the other. All right. So I'm just going to go ahead and use logarithm. All right. So you just go ahead and rewrite this over. Just like that. Now we're going to take the log of both sides. All right, so you must show that. So notice every step I'm writing, you have to show. So you got to show that you're taking the log or the natural log of both sides. Then you have to show the fact that you're going to use the power rule now. All right, so I'm going to rewrite this exponent as a product. So it's going to be in parentheses x plus 4 times the log of 7, just like that, equal the log of 430. All right, so that's your next step. Now remember, only approximate at the end. So don't all of a sudden approximate the log of 7 and approximate the log of 430. That is not what you are supposed to do here. You're only supposed to approximate at the end, because first of all, one of the things you had to do was to find the exact answer. Well, if you approximate now, that's no longer the exact answer. Okay? All right, now, you're trying to get x by itself, right? Okay, so notice I got to get rid of the parentheses. I'm going to get rid of the parentheses by using the distributive property. So then this becomes x times the log of 7, x times the log of 7, plus 4 times the log of 7, just like that, okay, equal the log of 430. All right, now, this is the only term that has the variable in it, so I got to get rid of this term. So I'm going to bring this term to the other side. Right now I'm adding 4 times the log of 7, so I'm going to subtract 4 times the log of 7 from both sides, just like that. And then this is 0 here, so I get x log 7 plus 0 is x times the log of 7 equal the log of 430 minus 4 times the log of 7. Okay? And then we're almost done. One more step and you're done. I got to get x by itself, right? Right now I'm multiplying x by the log of 7, so the opposite is to divide by the log of 7, just like this. And all you do is now say x equals, and just write what you see, write over what you see. The log of 430 minus 4 times the log of 7 divided by the log of 7. There is your exact answer. So that's the exact answer. Okay, now let's go and approximate. So remember what we did a while ago. Remember our discussion here. Keep that in mind. All right, so let's approximate. Okay, so you're going to say log 430, close the parentheses, minus 4 times the log of 7, just like this. Say 4 log, L-O-G, 7, close the parentheses. Now remember, that's your numerator, right? So now press equal. Press equal. So that's your numerator. Then you're going to say divide by the log of 7. Since the log of 7 is just one term, then just say divide by log of, make sure you press the right logarithm. This is common logarithm that we're using. Log of 7, close the parentheses, press equal, and you are done. So the approximation is going to be negative 0.884, because since that's an 8, right? 5 or greater, you add 1 to this digit. So negative 0.884. Okay? All right. Let's look at number 7. All right. Does it matter, number 7, does it matter whether I use common logarithm or natural logarithm? Does not matter. It didn't matter for any of the problems, but if this is base 10, it's easier to use a common logarithm. If this is base E, it's easier to use a natural logarithm. It'll make it a lot more efficient. But since I don't see that here, it does not matter. One using logarithm, common logarithm, or natural logarithm is not going to make it any easier. So let's just go ahead. This time, let's use a natural logarithm just to show you. So I'm going to take the natural log of both sides. All right. So I'm going to say the natural log of both sides. And then to get that to get the variable out of the exponent, I'm going to use the power rule. So this becomes 0.7x times the natural log of 8 equals the natural log of 815. All right, now I got to get x by itself, right? Okay, so just, you got to remember this. Remember this idea here. So it's like saying 2 times x times 3, right? Equal, let's say, 10. I'm just making this up. So to get x by itself, you can see that you're multiplying x by a factor of 2 and a factor of 3. So you could have just said this. You could have said, I'm going to divide both sides by 2 times 3. And that's true, right? And so you get x equals 10 divided by 2 times 3. Or you could have just noticed that 2 times 3 is 6, right? So you could have said 6x equal 10 and divide both sides by 6. Does not matter. 10/6, which is reduced, is going to be 5/3. All right. The point here is this, though. 0.7 times the natural log of 8 is not a whole number like 2 times 3 is. 2 times 3 is 6. So what I need for you to do is to recognize that if you're going to get x by itself, then you're going to divide, watch what I'm doing, you're going to divide both sides by 0.7 times the natural log of 8. Because remember, this is multiplication. 0.7 times x times the natural log of 8. And multiplication is commutative. The order in which you multiply does not matter. So 0.7 times the natural log of 8 is this. So you can divide both sides by 0.7 times the natural log of 8. Do not use your calculator, because remember, you want to find the exact answer and then approximate your final answer. All right, so I'm going to divide both sides by 0.7, the natural log of 8. Okay, now 0.7's divide out, the natural log of 8's divide out, and all you're left with is x. So you get x equal the natural log of 815 divided by 0.7 times the natural log of 8, and that is your exact answer. Okay, now let's approximate. All right, now listen carefully how we're going to approximate this. Okay, all right, now you have the natural log, the numerator is just one term right here, right? Okay, so the natural log of 815, close the parentheses. Now be careful with the denominator. So divide by, now this is 0.7 times the natural log of 8. 0.7 times the natural log of 8. You got to be careful. Since this is more than one factor, you need to put that in parentheses. I'm going to come back. I'm going to show you if you don't, what you're going to get. All right, so you got to put that in parentheses. So you're going to say in parentheses, this is where parentheses is important now, okay? Parentheses, you're going to need parentheses. Okay, so there's going to be in parentheses 0.7 times, oops, did the wrong one. Let me do this over. 0.7 or 0.7. Dang, I did it again. All right, let's do this over. 7, all right, times the natural log of 8. Now I got to close that parentheses here, and then notice this parentheses close this one, but I got to close this one. All right, and now if I press equal, that's going to be my approximation. So 4.605. 4.605. Okay? All right, now here's what would have happened if you had not used parentheses. Okay, if you had not used parentheses, you would have done this. You would have said the natural log of 815 divided by 0.7. That's what you would have entered, right? If you had not used parentheses, divided by 0.7, and then you would have said times the natural log of 8. Okay, close parentheses. Notice when I press equal, you don't get the same answer. Okay, it is important you remember this, that if this is more than one factor, see this is a product right here, you need to put that in parentheses, because if you don't, what I just did was this. Let me just show you what I just did. Okay, so what I just did, when I did this, I said the natural log of 815 divided by 0.7, and then I said times the natural log of 8. That's what I just did, right? Okay. What that means is this. The natural log of 815 divided by 0.7 times the natural log of 8. That's what this right here means this. And then if I write this as 1, fraction, that becomes the natural log of 815 times the natural log of 8 divided by 0.7. Notice, when I did it this way without parentheses, the natural log of 8, if I did it this way, is actually in the numerator. But my problem, the natural log of 8, was in the denominator. So it's important you understand now that when using your calculator, if you divide by a denominator and the denominator has more than one factor or has more than one term, then you need parentheses. Okay? All right, so let's remind ourselves how to use your calculator with this. You're going to say the natural log of 815, don't forget to close it, divided by, now I need parentheses because that's two factors here. Parentheses, 0.7 times the natural log of 8. Now remember, whenever you click on log or natural log, it inserts a parentheses. You got to close it, close that parentheses, and you got to close the denominator parentheses and press equal, and you get that. Okay? All right, now let's look at number 8. Okay, so number 8, notice it does not matter whether you use natural log or common logarithm. I'm going to use common logarithm. I have 5 to the x divided by 3 equal 0.7. Take the log of both sides, And then I'm going to use, and remember, you got to show this. All right, important. Remember the steps you have to show. Okay, so then you're gonna use the power rule now to get the variable out of the exponents. You're gonna say x divided by log 3. I'm sorry, x divided by 3 times the log of 5 equal the log of 0.7. All right, now I got to get x by itself. Now here's how I would do this. To get x by itself, notice I'm dividing by 3, right? So one of the things you learned is to clear your fraction. So let's go ahead and multiply both sides by 3. So this is what you would say. So I'm going to say times 3 and then times 3. So the 3's divide out here. So you get x times the log of 5 equals 3 times the log of 0.7. And then dividing both sides by the log of 5, you have your final answer. Just like that. All right, and so these divide out. So you get x equal 3 times the log of 0.7 divided by the log of 5. Okay? All right, so there's your exact answer. And then, so that's your exact answer. And now we're going to approximate this. Now, remember, look at your denominator. Your denominator is just one term, one factor. You don't see a 4 times here. If you saw a 4 times the log of 5, you would put that in parentheses when using your calculator. All right, so let's remind ourselves how simple this is now. So you're going to say 3 times the log, this is log, of 0.7, close the parentheses, and then there's my numerator, right? Press equal. I found my numerator, press equal. All right, so that's the numerator. Then you're going to say divide by. You don't need parentheses here. And some of you might going to say, well, I want to use parentheses because I'm still a little confused about the other one. Well, that's fine. Put parentheses. Put parentheses in the denominator. Log 5. And you got to close it, though. Make sure you close the 5 and then close the parentheses you just inserted. And you get this. So to the nearest thousands, to 3 decimal places, this becomes a 5 right here. So negative 0.665. Just remind you, though, you do not need parentheses here in the denominator. So all you have to do is say this. 3 times the log of 0.7, close the parentheses, divide by log 5. Don't forget to close the parentheses for the 5, though, and you get the same thing. Okay? All right. Number 9. Okay, so number 9 is a little bit more challenging, and it's a little bit more challenging because if you look at all the previous problems, the variable only appeared on one side. See that? In every one. The other side did not have a variable on that side. This one does. So it's a little bit more challenging, but it's doable. You have enough information now to be able to do this. I want to remind you, though, you have a base C. So since it's base C, it's more efficient to use natural logarithm. All right, so we're going to take the natural log of both sides. So I have e to the x plus 4 equals 6 equals 6 to the 2x minus 1. So I'm going to take the natural log of both sides, just like that. All right, now notice my variable appears in the exponent on both sides. So I'm going to use a power rule twice here. So you're going to say x plus 4 times the natural log of e equals 2x minus 1 in parentheses times the natural log of 6. Okay? We all know that the natural log of e is 1. That's 1 right here. And so x plus 4 times 1 is x plus 4. So I got x plus 4 equal. Now over here, I'm going to have to distribute the natural log of 6 because the natural log of 6 is not a nice number. It's an approximation, right? And you don't want to approximate this at this point because you're trying to find the exact answer. All right. And you only approximate your final answer. So what you have to do here is use the distributive property. So you're going to say 2x times the natural log of 6 minus 1 times the natural log of 6. So that's just minus natural log of 6. All right, so this one's a little bit more challenging. Now, notice we have this linear equation. x to the first, x to the first. Even though you have natural log of 6, don't let that throw you off. It's still a real number. To solve a linear equation, remember you got to bring all the variables to one side. So I'm going to bring this 2x natural log of 6 to the other side. So I'm going to subtract 2x natural log of 6, subtract 2x natural log of 6. So what I have here now is this, x minus 2x natural log of 6 plus 4 equal, this is 0, minus natural log of 6. So that's what I have. Okay? All right, now notice I have three terms here. 1, 2, 3. This one does not have x in it, so I need to bring it to the other side. So I'm going to subtract 4 from both sides now. So these divide, this becomes 0. So I get x minus 2x natural log of 6 equals a negative 4 minus the natural log of 6. That's what this is. And then notice this. Don't let that throw you off right here. It is very similar to something you've had before. Okay? So if let's say I had x minus, let's say, I'm making this up. Let's say bx. Okay? You remember, both of those terms have x in common, right? So I can factor out an x. So this becomes x times 1 minus b. Remember that? Okay. So basically what I'm saying here is that you're going to use factoring to isolate x. So both of those terms have x in common. So you're going to say x times, and then x times 1 is x, and then minus 2 natural log of 6. So that's what you have to do next. Equal, and it's going to rewrite this over. And now to get x by itself, right now you're multiplying x by 1 minus 2 natural log of 6. So now you can divide both sides by 1 minus 2 natural log of 6. Just like this. Okay? And so 1 minus 2 natural log of 6 divide out, so you get x equal, and that's your exact answer. Minus 4 minus natural log of 6 divided by 1 minus 2 natural log of 6. That's your exact answer. Okay, now let's approximate. All right, so be careful. Okay, remember what we talked about. All right, so there's your numerator. So you're going to say minus 4, a negative 4, minus a negative 4, subtract, see how it looks? Negative 4, subtract the natural log of 6, close the parentheses, and press equal. That's your numerator. Okay, now notice my denominator, you're going to need parentheses here. So you have to use parentheses. If you don't, you're going to get a different answer than what you should. So you're going to say divide by, divide. So you found your numerator. Now you can divide by the denominator. Parentheses, and you just write out what you see. 1, watch how simple this is. 1, subtract 2, natural log of 6. Don't forget to close that 6, though. And then you got to close your denominator. And then press equal, and there's your answer. So there's going to be, to the nearest thousandths, that's going to be a 2 right here, because that's 5 or greater. That's an 8. So 2.242. Oops, let's do it again. 2.242. Okay? All right, so notice I had to put parentheses here in the denominator when using a calculator. So do the best you can remembering that. You have to remember that. All right, and so that was it. That was let's go ahead and do another one like this. So let's do number 11. I'm just going to do another one. So here's number 11. Okay, so let's do this one. So number 11, let's suppose we had 2 raised to the x plus 3 equal 3 to the 2x minus 1. All right, just make that up. All right, now notice none of those bases are E or 10. So it does not matter whether I use common logarithms or natural logarithms. I'm going to use a logarithm, common logarithm. So let me go ahead and rewrite this over. Don't make it difficult. It's not that bad. So you know that's the first thing you have to do. Then my variables are in the exponent, so I'm going to use the power rule to get those variables out of the exponent. So x plus 3 times a log of 2 equals 2x minus 1 times a log of 3, right? Okay. Now, you know at this point that you're going to use a distributive property. Okay? So x times the log of 2 plus, and then 3 times the log of 2. Okay? Equal, and then the distributive property here as well. 2x times the log of 3 minus, and then 1 times the log of 3 is just the log of 3. Okay, so that's where I'm at. So I have this linear equation. And so I need to bring, see these terms that have x's, I need to bring to one side. All right, and then I'm going to take this and bring it to the other side. So at this point, a lot of students will say, we'll not even show this little part, and that's fine. Just be careful. You're going to have to say x log 2, and then when you bring this over, see this is a positive 2x log 3, then it becomes minus 2x log 3 equal. And then when I bring this positive 3 log 2 to the other side, it becomes a negative 3 log 2, and then minus log 3. Okay? All right. So when you bring this to the other side, you get this. When you bring this to the other side, you get that. Okay? Now, just like we did a while ago, remember what we did with this one? I'm trying to solve for x. Well, both of those terms have x in it, so I'm going to factor out an x. So I get x times, and in parentheses, the log of 2 minus, and then 2 log 3 equal the other side, negative 3 log 2 minus log 3. And then finally, all you're going to do, and you're almost done, all you're going to do is, to get x by itself, is divide by this number right here. That's a number. That's a real number. And when I do that, you're going to show this, just like this. What you do to one side, you do to the other, right? Okay, and you're going to say x equal, and you're going to rewrite this over, and there is your exact answer. And that's all you do. That's your exact answer. Now, oops, exact. All right, now let's approximate. Remind ourselves how to do this now, okay? All right, so let's find the numerator first. So the numerator, you're going to say negative 3 log of 2, close the parentheses, subtract log of 3. Log of 3, close the parentheses. That's my numerator. Press equal. There's my numerator. Okay? Then we have to divide it by that denominator. Now notice that denominator is more than one term. So what do we need? We need parentheses. So divide, and then put parentheses. Parentheses, and then you just write out what you see. Log of 2. Don't forget to close the parentheses for the 2, though. Subtract 2 log of 3. Don't forget to close the parentheses with a 3. And then remember, don't forget to close that original parentheses that you put. All right, and then press equal, and you are done. So to the thousands place, that's going to be a 3 right here, because that's 5 or greater. That's a 9. So 2.113. So there's approximately equal to 2.113. All right, and so that's it. So I think you should now have a very good idea how to solve exponential equations using logarithms.